All right, we're in the helicopter flying handbook. We're in chapter 7, page 2, performance charts. In developing performance charts, aircraft manufacturers make certain assumptions about the conditions of the helicopter and the ability of the pilot. It is assumed that the helicopter is in good operating condition and the engine is developing its rated power. The pilot is assumed to be following normal operating procedures and to have average flying abilities. Average means a pilot capable of doing each of the required tasks correctly and at the appropriate times. Using these assumptions, the manufacturer develops performance data for the helicopter based on actual flight tests. However, they do not test the helicopter under each and every condition shown on a performance chart. Instead, they evaluate specific data and mathematically derive the remaining data. All right, autorotational performance. Most autorotational performance charts state that autorotational descent performance is a function of airspeed and is essentially unaffected by density, altitude, and gross weight. Keep in mind that at some point the potential energy expended during an auto rotation is converted into kinetic energy for the flare and touchdown phase of the maneuver. It is at this point that increased density, altitudes, and heavier gross weights have a great impact on successful completion of the auto rotation. The rotor disc may be able to overcome the downward momentum of the helicopter and provide enough lift to cushion the landing. With increased density, altitudes, and gross weight, the lift potential is reduced and higher collective pinch angle of incidence is required. The aerodynamics of auto rotation has been presented in detail in Chapter 3, Aerodynamics of Flight. Hovering performance, page 3. Helicopter performance revolves around whether or not the helicopter can be hovered. More power is required during the hover than in any other flight regime. Obstructions aside, if a hover can be maintained, a takeoff can be made, especially with the additional benefit of transitional lift. Hover charts are provided for in-ground effect, IGE, hover, and out-of-ground effect, OGE, hover, under various conditions of gross weight, altitude, temperature, and power. The IGE, the in-ground effect, hover ceiling is usually higher than the out-of-ground effect, hover ceiling, because of the added lift benefit produced by ground effect. See Chapter 3, Aerodynamics of Flight, for more details on IGE and OGE. A pilot should always plan an OGE hover when landing in an area that is uncertain or unverified. As density altitude increases, more power is required to hover. At some point, the power required is equal to the power available. This establishes the hovering ceiling under the existing conditions. Any adjustment to the gross weight by varying fuel payload or both affects the hovering ceilings. The heavier the gross weight, the lower the hovering ceiling. As gross weight is decreased, the hovering ceiling increases. Sample hover problem 1. All right, let's check some of these charts and stuff before we go over. Okay, so far we've got this chart, and we're about to go do a question. All right, sample hover problem 1. You are to fly a photographer to a remote location to take pictures of the local wildlife. Using figure 7-1, can you safely hover in ground effect at your departure point with the following conditions? Pressure altitude is 8,000 feet. Temperature is plus 15 degrees Celsius. Takeoff gross weight is 1,250. RPM is 104%. Wow. First, enter the chart at 8,000 feet pressure altitude. Point A. All right, 8,000 feet pressure. Then move right until reaching a point midway between plus 10 and plus 20 lines. All right. Point B. Yep. Okay. Plus 10 and point 20 line. From that point, proceed down to find the maximum gross weight where a 2-foot hover can be achieved. In this case, it is approximately 1,280 pounds. Since the gross weight of your helicopter is less than this, you can safely hover these conditions. Yeah, because we're going to be 1,250 pounds. Okay. Cool. That's our hovering performance. I think we're going to have a question 2. Alright. We'll hold off there because I don't want the videos to get too long. So we're on chapter 7, page. That was page 3, pretty much. Page 2 and 3. Alright. See ya.